Me, Professor Childers again. Today I'm going to talk about wire termination. Wire termination is very important, and I'm holding in my hand a piece of number 12 solid wire. Wire termination is very important because the weakest point in any electric circuit is the point of termination. Now, what does that mean? That means that whenever you wrap a wire around a piece of wire around a screw, or whether you put it up underneath a terminal block, or under a circuit breaker, or a relay contact, or a relay subbase, or anything like that, that point of termination can be and will be the weakest point in a circuit. Now, how do we keep from doing that? Well, I'm going to demonstrate and show you how to terminate a switch or a receptacle. So, first of all, we have our Klein strippers. And these are very nice strippers. They're comfortable. You want to look at tools that are comfortable in your hand because you're going to be using them all day long. Next, what's required is a flathead screwdriver. This happens to be a Klein insulated flathead screwdriver. Very comfortable. I think it's rated for about 2,000 volts. The shaft is insulated, so if you're going to use it in a live electrical panel with live electrical circuits, you're insulated. You have a plastic handle, and you have a rubber insulation on the handle. Next, you're going to be needing a pair of needle nose pliers. And my particular preference is the channel lock needle nose pliers because they have the wire cutter built into them. And they also are narrow and tapered and slimmer than the Klein needle nose pliers. Now, some people like the Kleins because they're a little heavier duty, but when you're getting into a control box or you're trying to dig your fat little fingers into a box, these work really good. The last tool that I'm going to show you is your favorite friend that you'll be using forever. This is the lineman side cutter pliers. Now, we call them linemans, we call them side cutters. Some people use them as hammers. You can look at this one. I've got hammer marks on it from beating on the ends of screwdrivers to tighten up lock nuts and connectors and boxes. If you notice, this also has a ding mark in the cutter blade from me cutting a hot wire, which you're not supposed to do. These have the heavy-duty, comfortable grips because you're going to be using these all day long. I've been carrying these for probably about 10-12 years. And they last forever. They have different versions of these. They have one that has a anvil on the back of this so that if you're pulling wire on a fish tape, that you can use this double-handed as a leverage point. You can also use the anvil up in the front of the pliers to pull the fish tape with. Very similar to this, just as long as you're not going to be cutting the fish tape. Also, these are great for knocking a hole into drywall because of the tapered head. If you knock a hole into a drywall, this is actually a 1/2 inch for a 1/2 inch flex or 3/8 MC cable. As long as you take care of your lineman's pliers and keep them lubricated, you'll get a little bit of surface rust on them, but they'll last forever. Okay. So basically, I've got wire nuts, I've got my tools, I've got wire, and I know it's white wire instead of colored wire, but it's just a scrap piece of wire for demonstration. I've got a 15 amp receptacle, and I've got a really nice toggle switch. So if you look at the toggle switch or the outlet, you've got different points of termination. On a switch, you're going to have the two terminals, one for the hot and one for the switch leg, and then you're going to have a ground wire lug. Now this green screw is for the ground wire only. It's not for the neutral. This is a self-grounding switch. Okay, and the definition of a self-grounding switch is simple. Once the switch is installed into a metal box, it's grounded. However, by code, you've got to run a ground wire to this switch from the box. Also, on the receptacle end of it, this is a back-wired receptacle. Okay, this has little plates on it. You stick the wire up underneath and tighten it up. That is good for a loose connection, eventually, because you have to remember the AC current, or AC voltage, pulses every 60th of a second, so it's kind of like a hammer drill. And as it hammers, it's going to cause issues. So this as well is a self-grounding outlet. Okay, you've got the neutral and the hot side, and when we wrap wires around these, we wrap them around clockwise, because as you tighten the screw, you want the wire to tighten up around the screw, and I'll demonstrate that in just a second. Again, this is a self-grounding outlet. It'll come with two 632 screws on it, just like the switch will, and the reason for that is because that's what holds us into the box. Now, if you're doing residential, you're going to end up with a ground wire coming out of the box. That ground wire will attach here. Your hot will attach on the brass screw. Your neutral will attach on the silver screw. Okay, but with the switch, it doesn't matter which one of these is the hot or the neutral on a single pole switch. On a three-way switch, it does make a difference. Now, the other thing that's very important is when you're installing devices like switches and outlets into boxes, it's very important to have the switch cover or the outlet cover covering the device when you're done. Because in the event of a short circuit, arc flash can create up to 35,000 degrees centigrade in heat. So if you have a dead short, it will cause a fire. Okay? So I'm going to demonstrate how to successfully terminate a wire onto a switch or an outlet. So first you want to strip this. Alright, then you want to take your needle nose pliers. You want to take this and you want to bend this at about a 45-degree angle. Then you want to come up here and you want to grab this and you want to bring a loop around. And you want to make it look like a question mark. Okay? Simple. Then what you'll do is you'll take and you'll wrap this wire around the screw, just like that, and then you'll tighten it up with your screwdriver. Now you've got a successful connection. It looks clean, it's functional, and it's not going to loosen up. Now, in the event that you take and strip too much copper wire back here, then you've got an issue of a potential short when you stuff this back into the box, because you're going to fold these wires back into the junction box that this device installs into, and if you've got too much copper, it could touch against the ground and cause a short circuit. Then you've got another issue. Okay? Now, the one thing about these strippers is that it also acts as a wire cutter. Simple. So now I'm going to show you the proper way to splice wire using a wire nut. Okay, I've got wires stripped. So what you can do is you can strip both ends of this wire, just like this. And then you take your needle nose pliers and you grab this number 12 wire, very similar to this. Okay. Now what you're going to do is you're going to take your lineman's pliers and you're going to take and twist these wires together. This is called a compound splice. Consequently, this is better conductivity in the splice. You will not have any problems with it down the road. Back in the day, we used to call these lineman splices because the guys that ran the wires for Pony Express and the telegraph wires made these kind of splices. Now, I'm going to reach into the bag once I've got my splice, and I'm going to grab me a wire nut to put on here. Now, the wire nut is only going to cover so much of the copper on this wire. So if I put this on, and this one here is a little bit long, if you can see the copper here exposed, that can be a problem when you're putting this into a box. So as a lineman's secret, the thickness that you want to have this copper wire coming out is actually the thickness of a pair of lineman's pliers. So what you do is you take your lineman's pliers, turn them over so your cutting edge is on the outside, line up the insulation of the wire with the inside edge of the lineman's pliers, okay, and then just trim that off. Simple. Now your wire nut will go on here, and you have no extra copper that's exposed. And that is the trick of a pair of lineman's pliers. If you go the thickness of the pliers right here on the end of that copper wire, that will give you an exact measurement for a wire nut to be installed on it. Okay? Now, when you're installing 3 or 4 different wires under a wire nut, once you get those 2 spliced, then you can add your 3rd, your 4th, or your 5th wire. Okay? So that basically covers how to terminate wires. And one more thing that's important is that you may run into aluminum wire some point in time in an older mobile home. Aluminum wire cannot be installed on a standard Home Depot 39-cent, 89-cent switch or an outlet. What you need to do is you need to be very careful, and you need to look at the box itself and make sure that the box says ALCU. ALCU means aluminum on the periodic chart of elements, and Cu means copper on the periodic chart of elements. And what's important about that is that when you have 2 dissimilar metals like aluminum and copper, and you meet them together under a wire nut or on a switch or an outlet, you have what we call electrolysis, which is a small generation of electrical charge. That small generation of electrical charge can create a problem with heating over a period of time. And when you have that heating, generally what happens is it will melt or burn a wire nut, and it will also cause issues down the line. So we use a product called No-Lox, N-O-L-O-X. It's a black gritty paste like grease that you put on there, and it prevents electrolysis. Okay? Now, also on this, once you make your wire nut up, what you want to do is you want to pull on it and make sure it doesn't come off. In the event that you pull on it and it comes off like that, then you've got an issue. The other thing about wire nuts is a lot of guys just take and hold the 2 wires together, run a wire nut on it, and call it good. That's not really the true way of making up a splice to prevent it from causing a fire down the road. Anyway, thank you very much. This is Professor Childers. Keep watching our videos.